All right, so now we've talked about how to use Pascal's triangle to find the coefficients of a binomial expansion, or how to use combinations to find the coefficients in a binomial expansion. Now let's concentrate on how to find a specific term in a binomial expansion. So I would like to find the 18th term of 3x minus 4y being raised to the 22nd power. The last thing I want to do is write out the first 17 terms to lead me there. So I just want to think about the patterns that are happening in this expansion. Now, if you think about raising x plus y to the third, okay, I would use row 3 of Pascal's triangle, and I would use those coefficients. So 1, 3, 3, 1. And then I know my x's start to the third and then decrease for each successive term. Where the y's do the opposite. They start with the smallest and work their way up. Now, what I would like to do is compare each of these terms to what term number they are, thinking back to our sequences. So here's our first term, and our second, and our third, and our fourth. Because if I can notice a pattern here, then I won't have to write out the first 17 terms just to get to the 18th. So here's what I'm seeing. My first term has an exponent of y to the 0. My second term has an exponent of y to the first. Third exponent is y squared. Fourth is y cubed. So can we agree that the exponent is always 1 less than the term number? And more specifically, the y exponent is always 1 less than the term number. Okay, so if we can think about the term number, that the y exponent would be 1 less than that, then that's really all the information we need to find this specific term. So again, if we're talking about the 18th term, that means my y exponent is 1 less than that. It's going to be 17. And I can build the term just by knowing that. Okay, so let's go ahead and say we know that the y is going to be to the 17th power. Now, in this expansion, it's not just y that's in this binomial, it's actually a negative 4y. So I'm going to write this as negative 4y is being raised to the 17th. Now, we know for each term in our expansion, the total exponent is 22. I've already gotten y to the 17th. Any extra exponents need to go on the x. But again, not just x, it's 3x. So 3x needs to be raised to the 5th because the 5 and the 17 give us a total of 22. Now I can work my way back to what the coefficient would be. I'm going to use a combination because I don't know what the 22nd row of Pascal's triangle looks like. Okay, so in my combination, the top number n is always that biggest exponent, which in this case is 22. And then the bottom, again, we can pull either the x exponent or the y. I have been choosing the x. So this is the basic format of this 17th term. And now I'm going to go ahead and multiply it out. So on my calculator, I'm doing 22C5. That gives me a value of 26,334. But I also need to know what 3 to the 5th is, and that is 243. And I also need to know what negative 4 to the 17th is. And that is, something in scientific notation, which looks like negative 1.7, I'm going to cut it off, 2 times 10 to the 10th, y to the 17th. Are you surprised that it's so big? You shouldn't be. Okay, so I've kind of done each individual value, but now to get my final term, I need to multiply these guys together. So I'm going to take my 26,334 times 243 times negative 1.72 times 10 to the 10th. So I'll type those in my calculator. And of course, I'm seeing a number in scientific notation. It's huge, and it is about 1.09 times 10 to the 17th, negative. So this is the final coefficient for that term. And then I can write my x to the 5th and y to the 17th. So again, the key was recognizing what that y exponent is going to be. Whatever term it is that you're asked to find, take one away, and that is your second exponent.